Hello guys, I'm Chava the scientist. Welcome to this wonderful platform that makes it possible for you to learn from wherever you are safe, isolating yourself during this critical time, because it's very important to stay at home, isolate yourself from the public. Instead of gallivanting out there, it's important to stay indoors and do your chemistry, because chemistry is very important. Without chemistry, we cannot solve this serious pandemic that we are faced with here. We need chemists. We need to do chemistry and come up with a vaccine for this pandemic that is messing up with our lives, messing up with our education. So without any waste of time, I want us to jump into the type of chemistry that we'll be doing today. So today we'll be doing organic chemistry. Under organic chemistry, we'll be naming organic compounds, and we'll start off with the simplest organic compounds called hydrocarbons. So while naming these compounds, we are going to use one of the most famous and international way of naming organic compounds, which is called the IUPAC naming, which is IUPAC. This one is an international method of naming, saying you go to India, you go to China, you go to USA, you are going to find them using this same method that we are using here, which stands for International Union of Pro Applied Chemistry. So yeah, without any waste of time, let's get to naming. But before we start off with this naming, it's very important to familiarize yourself with naming compounds, right? With some certain terminology. Like I just said, today we're naming hydrocarbons. Hydrocarbons. So someone there at home is wondering, what are hydrocarbons? Hydrocarbons are organic compounds consisting of hydrogen and carbon atoms only. I need to underline this only, because hydrocarbons, they only have hydrogen and carbon atoms. The moment you see another atom which is not hydrogen and carbon, you must know this is not a hydrocarbon. So those are hydrocarbons. For an example, here I've got a table of the hydrocarbons that we have here. We've got alkanes, alkenes, and alkynes. So those ones, they are hydrocarbons. And then you see here from my table, my wonderful table, I want us to name each and everything that we see here, so that we are very familiar. We are very familiar with this. And then we can jump to the naming. The first term that I want us to look at here, it's a homologous series. What is a homologous series? We have already covered hydrocarbons. What is a homologous series? A homologous series is a group of compounds, organic compounds though, with the same general formula and functional group. So you see here, this is our general formula, this is a general formula, this is a functional group. So alkanes, this tells you that alkanes, they are a homologous series because they've got same general formula and the same functional group. Alkenes, they are a homologous series because they've got the same general formula and the same functional group, etc. Alkynes, you see. So I just introduced the new term here called a general formula. What is a oh, sorry, I'll get back to the general formula. Let me deal with this one first, called the functional group. What is a functional group? What is a functional group? A functional group is a bond, a atom or atom that describes the chemical and physical properties of a compound. You know that I'm using the term compound. So here we are dealing with organic compounds. You must know when I'm using a compound, I'm saying organic compounds, because I just said we are dealing with organic compounds today. So I've just defined a functional group now. As you can see here, this is a functional group, that is a functional group, and that is also a functional group. There's this functional group. One of the most famous functional group that we know out there is this one, OH. OH is one of the most famous functional group that Begicele is denying people out there to save them from the coronavirus. OH, alcohol, you see? This OH tells you this one is an alcohol. So this OH is a functional group. It will tell you that your compound is an alcohol, because you will see on your compound it will have an OH. So it's an alcohol. Let's go on here. We have already defined a functional group. We have already defined a lot of things now. We can check out the general formula. You see, from the general formula here, it's going to tell us, from the general formula we can use the general formula to calculate our molecular formula out there. You just plug in the number of carbons. N is the number of carbons. You just plug in the number of carbons. You see, for an alkane, let's say for an example, you've got propane. Propane has got 3 carbons, so it will be C3H into 2 times N. What is N? N is the number of carbons, which are 3 plus 2. So we'll have C3H, 2 times 3 is 6 plus 2, C3H8. So C3H8 will be your propane. Now let's jump into the business of the day. We said today we'll be naming organic compounds, right? I was just talking of propane. Maybe many of you don't know what is propane. So I'm here. We'll be able to name propane. How do we come up with this propane? So when you are naming an organic compound, it's an organic name is composed of 3 parts, which is a prefix, then you've got a, let me say, a root, and then a suffix, right? With the prefix, a prefix tells you the position and names of substituents in their alphabetical order. It's very important when you've got a prefix, you name them in their alphabetical order. And then the root tells the root is made up of number of carbons in the longest chain of in the longest chain or main chain, in the main chain. And then the suffix, it talks about the ending. You see, as you can see, suffix here, suffix. The suffix is determined by a homologous series. That means if you've got alkanes, your suffix will have your compound will have the suffix "ane". You've got alkenes, your suffix will end with "ane". So when you have got a name, it's made up of a prefix, root, and a suffix. You see, with this information in our mind, we can try and name some compounds. You see, when I defined my prefix, I said it tells us position and names of substituents. So you are wondering now, what is a substituent? I'll just show you in a minute. Let's say you've got a compound. I want us to start off with the propane. The propane I was talking about. C, right. This is propane, right? So when I want to name propane, right, in this case, in the case of propane, we don't have a substituent, because a substituent is a certain group that replaces a certain hydrogen here. Let's say this hydrogen is not here, is replaced by a certain group. That group, we call it a substituent. So right now we have got all hydrogens and carbons only. There's no substituent. No hydrogen is replaced by any group here. So we don't have any substituent. So we don't have any substituent, so we don't have a prefix for this particular name. So we go to our root. Our root, it tells us, our root, we calculate the number of carbons, right? So we start off when we have got 1, it's meth. You see, when you've got 1 carbon, it's meth. 2 is earth. Number 3, when you've got 3 is prop. When you've got 4 is but. And then when you've got 5 is pent. 6 is hex. And then let's go on. 7 it's hept. And then 8 is oct. And then 9 it's nano. And then 10 is deca. So I'm just going to end at 10 because you can even go on and on and on. So for you, I will just end at 10, but I don't think they'll even go up to 10, maybe 7 or 8. Right now we want to name this compound. We said it doesn't have a prefix, right? So we need to go to our root. We said root is determined by the number of carbons in the longest chain. This is our chain. It's 1. You've got how many carbons? You've got 1, 2, 3. And then you go, what is your root name here? You go, you've got 3 carbons in the longest chain. This is the longest carbon chain. So you go up to 3, and then you see 3 is prop. So you have your root. You are making a name here. It's prop, right? And then you go again. We are done with the root. We want the suffix, right? And then you see, what is the functional group now? You see, you go here, you check the functional group. You see, it only consists of single bonds. You see, for this one you've got double bonds. As you can see, if you've got double bonds, then it's a different functional group. But you check your compound, propane. Propane only has single bonds. Now you have got it in mind that no, this can be an alkane. You see, so when it's an alkane, the suffix is ane. You see, so that means your name should end with ane. So you have got the root, which is prop, and then you add the ane, and that's how you come up with the name propane. You see, so let's try another name now. Let's try to name another compound. Let's name another compound. I want to remove that part which talks about suffix so that we can be guided into making names. Let's see. Let's say we've got C double bond, C, then C, right. You must remember a carbon can only accommodate how many hydrogen? It's 4. A carbon can only accommodate 4 bonds. 4 bonds. Not hydrogen can accommodate 4 bonds. When it's more than 4, then there's something wrong with your structure. So we've got so this time we must have 2 hydrogen because a carbon can only accommodate 4 bonds, right? Now let's name this one, right? You can think about it. Think any prefix, because we have all our hydrogens. You see, there's no hydrogen that has been replaced by another group or substituent, right? So we don't have a prefix again, and then we go to a root. A root, we calculate the longest chain of carbons. It's 1, 2, 3, 4, right? Now, when you are calculating your longest chain, you need to start with the carbon that is closest to the functional group. You don't start counting from this side. You will realize very soon when you go to substituents that why do we do this thing. Now we have got how many? It's 4, right? So our root tells us it's 4. When it's 4, it's bute. From there we've got our root name, which is bute, right? Now we go again. What is our functional group? We go here. Do we have single bonds? Yes, we do. Do we have double bonds? Yes, we do. The moment we have double bonds, they supersede the single bonds. So that means you will determine your name using the double bonds, right? So your suffix, you see a double bond, it's an alkene. So your suffix is in, you see? So it's butene. Now, let's say you put a triple bond, it will be an alkyne, so it will end with butane again. So let's try it. I want us to try them all. You see? In the interest of time, I want us to check something, because it's the same story for alkynes, the same story. So let's try something new. I want us to try something new. Let's say we've got C, H, C. Yeah, you see? Now this comes, so that must be an H. So in closing this video, I want us to try and name this one. Sorry for that. I want us to try and name this gigantic thing. So you must relax when you see such things. Don't panic. So we start off a prefix, right? Prefix. Do we have any prefix? Let's check. We have got all hydrogens here. But you see here we've got a hydrogen. Instead of a hydrogen here, we've got a branch. You see? We have got a branch this time around, right? So we do have a prefix. And then we go to our root. We said when we deal with the root, can we calculate the longest chain of carbons? We can say 1, 2, 3, 4. No, that's wrong. The longest chain is not 4. So you need to calculate the longest, which is 1, 2, 3, 4, 5. You see? That will determine your name, your root. So it's 5. So it's pent, right? So you have got a pent, right? But we said we had a prefix. We'll get back to the prefix, right? So our suffix, you see we've got single bonds. So you don't have a double bond, so it's all single bonds. So when you have all single bonds, what do you say? It's an alkane, right? When it's an alkane, you expect it to end with ane, so it's pentane, right? So now we need to deal with this. As you can see, we name this part. Now we need to deal with this branch here. How do we deal with that branch? We deal it with the prefix. This is a substituent. You see, it has substituted as hydrogen there. You see, so now when you name a substituent, you just again you count the number of carbons in your substituent, and then you put the suffix YL. You see, so it's one carbon, again it's methyl. You see, two carbons, ethyl, you just add YL on the end. 3 propyl. You see, those ones are substituents. So for this one, because our branch has got only one carbon, so it's methyl, right? So we can go prefix is methyl, root is pent, and then suffix is ane. So you've got methyl pentane. Now we are not done. Where is this methyl located? We need to also talk of the location, because this methyl can be somewhere here, somewhere there. We don't know. It can be anywhere. So we need to also put the location of our methyl. You see? So starting from here, we said we started from this side. 1, 2, 3, right? So on carbon number 3, we've got a methyl. So we say 3-methyl pentane. That is the name. Suppose they were like there's another carbon here. H and H. You see? So you can start again this side. 1, 2, 3, 4. Now it's 4 methyl instead of 1, 2, 3 methyl. You see? So it's very important that you start counting from the side which is closest to the functional group. You see, so that's why I start from this side, because you see there is a substituent, so we need to start calculating from this side which is closest. You see, not starting from this side. Thank you very much. That's it for today. We will come back with more and more examples of this wonderful chemistry. I hope you stayed at home, stay safe, isolate yourself from the public, so that you can be able to come back tomorrow and solve chemistry. Thank you very much for watching this video. I hope you enjoyed.